we are going to see how NTOPNG and NProbe intrusion prevention system can be used together to have visibility and policy the traffic of a smart home. NTOPNG and NProbe, for this demonstration, are both being run on an embedded smart Raspberry Pi version 4, and the Raspberry Pi is also used to create a Wi-Fi network that can be used by all the smart devices to connect and reach the internet. To simulate a smart home, we have created a test bed with smart cameras, smart sensors, lamps, and smart plugs. And we have connected all those IoT devices to the Raspberry Pi via the Wi-Fi network it creates. Indeed, the Wi-Fi network the Raspberry Pi creates is called Totem for the sake of this demonstration. But let's have a closer look at how our test bed looks like. This is the test bed we have used. We have 2 smart cameras, a smart lamp, and 4 different smart plugs. We have 2 TP-Link smart plugs and 2 Sonoff smart plugs. We also have a door sensor that is actually attached to a window. And this is the Raspberry Pi where all the magic happens. This Raspberry Pi creates a Wi-Fi network that is joined by all these devices, and then it checks and inspects their traffic to make sure it's secure, it's legitimate, and then only after all those checks have succeeded, the traffic is allowed to reach the internet. Let's now have a closer look at NTOPNG. Specifically, we will have a look at the visibility we can gain using NTOPNG, and we will also look at how we can use NTOPNG in combination with NProbe intrusion prevention system to enforce policies on our smart home devices, to block unwanted traffic, to block suspicious traffic, and to make sure that only legitimate and secure traffic is able to go through and reach the internet. This is the list of devices that are currently connected to the Wi-Fi network that is policed and inspected by NTOPNG. So we have the Sonoff door sensor that is an IoT device. We have the 2 Sonoff smart plugs, the 2 video cameras, along with other devices. For all these devices, we see their MAC address, manufacturer, and the traffic they perform towards the internet and from the internet. We can also have a look at their individual flows. For each flow, for each communication flow, we see the application protocol along with other information. But let's go back to the list of devices. The interesting part of this project is not only having visibility of the traffic these devices perform. The interesting part is also the ability to enforce policies for the traffic generated by these devices. To see how we can enforce policies on the traffic generated by these devices, we need to have a look at the host pools. Host pools are basically groups of hosts that are policed using the same policy. So for the sake of this project, we are going to create an host pool called IoT devices. and we are going to assign all our devices to that particular host pool. Indeed, we can go here to pool. We have an IoT devices, and here we have the list of MAC addresses belonging to our smart devices that we want to policy. The question is now, how can we implement and enforce policies for our IoT devices? Well, we have a key here that we can use to enforce policies. Specifically, here we configure traffic policies for IoT devices. Basically, we have a default policy that we can choose to be pass or drop, and by default we have chosen drop, because we only want to allow a small set of trusted protocol for our devices. Specifically, for the devices belonging to the host pool IoT devices, we only allow protocols such as SSDP, TLS, DNS, NTP, Amazon, and a few more. The rest of protocols are automatically blocked by NTOPNG. We can also create policies for categories, countries, continents, but the other very interesting part of this is that we can also create and enforce security policies that depends on several risk factors associated to the traffic. That is, even though the traffic generated by our devices is allowed because it's HTTP or Amazon or another one, it can still be risky or suspicious because it can be used to perform malicious activities such as SQL injection, remote code execution, as well as other potentially dangerous activities. So with this configuration, we can also block individually all the suspicious or potentially risky activities of our devices. The system that is running has also the ability to learn in the background. This means that you can let your devices run for a day or a week, and then you can click Auto Configure to automatically create traffic policies that are assumed to be safe for the set of devices falling inside this host pool. So now everything is running, the system is protected, and these traffic policies are being enforced. This means that no device belonging to this pool will be able to perform remote code execution, SQL injection, or do suspicious file transfer, because these suspicious activities will be blocked before they can actually be disruptive and reach the internet. It's also interesting to look at the alerts that are generated by the system, because the system not only policies the alerts, not only policies the traffic, it also creates alerts when it detects suspicious activities or suspicious traffic. Alerts are accessible from this page, and we can look, for example, at flow alerts. We have time series of flow alerts, and we also see among the top alerts we have applications non-standard port or suspicious device protocol and other alerts as well. Let's have a look at suspicious device protocol. Among these protocols we have, for example, client application unknown, not allowed for video application policy. So this is our smart camera. This smart camera basically is generating unknown traffic, that is traffic that is not recognized as belonging to any of the recognized protocol. Let's have a closer look at the alerts. The alerts are shown as a time series here, and we have the top hosts, that is the top sources of alerts, and the top alerts they generate. Let's pick one of these alerts, for example, unsafe TLS ciphers. If we open these unsafe TLS ciphers, we see that there are 3 suspicious communications towards Amazon using TLS. But what does unsafe TLS ciphers mean? It means that this device, that is actually the smart sensor connected to the window, is communicating with Amazon using a weak TLS cipher. We can also look at other alerts as well, and we have applications of non-standard protocol, suspicious device protocol, and so on. If we look at applications of non-standard port, we see that this device is doing HTTP on port 808015. You know that HTTP is run on the well-known port number 80, but actually this device is running HTTP. This is one of our video cameras, is running HTTP on the non-standard port that we have seen. So to wrap up, in this video we have seen a demonstration of how our NTOP-NG and NProbe intrusion prevention systems can be both run on an embedded Raspberry Pi to have visibility and enforce policies on a smart home. This will ensure to have a protected smart home with devices only performing secure activities.